Great. So thank you for being here for the third presentation of our session on education and diversity. Our third speaker is Penny Rheingans, hope I did that correctly, who's a professor at University of Maryland, Baltimore County. She's been there 17 years, as I understand it. She got her PhD from this department in 1993. And she's going to be talking about broadening participation in computing, lessons from the literature, and observations from the front lines.
Thanks, Mike. All right, so I'm going to start with stories. I'll admit up front, I'm really old. So think back to the early 80s. I arrived at college. I needed a major. I thought it was going to be something in the social sciences. Maybe I'd become a lawyer. So my first semester, I took the beginning of that track. I took the first economics class. I also, because it was the 80s, decided I was going to take a computer science class because computers were going to be everywhere. And so that first semester, I was really, really, really good at economics. It came easily, it made sense, I got great grades, it was fabulous. Computer science, on the other hand, was like beating my head against the wall, right? It was hard. My brain didn't go that way. By the end of the semester, I was sure I needed to be a computer scientist. Many things in my life have kind of followed this path. At that time, there were no women on the faculty where I was at Harvard. There were very few women in the classes. In fact, in most of them, once I reached the upper level classes, there were two of us. And we bonded and we remained best friends. With the social observation skills of a typical computer scientist, I didn't realize I wasn't supposed to be a computer scientist, right? Society was sending me these really strong messages and I wasn't hearing them, so I persisted. And then I went on to graduate school. I arrived here. By then it was the late 80s, and things weren't really different. When I got here, there were no women on the faculty. At any given time, or there was one briefly and she was gone before I graduated. There were only a couple of us at a time among the graduate students, and mostly I could ignore that. Occasionally, it flew up in my face. One semester, a group of us in graphics went on a field trip. So we spent the first half of the semester reading papers from famous research labs. And then we went and we visited a number of those places. And we were poor graduate students. We slept many people to a room, right? 4, how many, right? 5, whatever. I was the only woman who went on the trip, right? It became concrete just how few of us there were. I'd like to be able to say, okay, that was the 80s. It was bad in the 80s, right? Yeah, Gary knows where I'm going. Okay, it's worse now. Okay, this comes from NCWIT's directory. If you look at things, if you look at the high school level, you know, in all people who take AP exams, 56% of them are female, right? Calculus is about even. Computer science has the lowest percentage of women taking it of all of the AP exams. If you look at percentage of women earning degrees, so overall women earn for 57% of college degrees. Okay? In 1985, which is when I graduated from college, there was 37%. They weren't in my classes, but they were somewhere, right? In 2013, that was down to 14% at major research universities. Right? Graphically, I'm still a viz person. It looks like this. If you were an engineer, you could say we started out and there were tiny numbers of us and we're getting better, right? If you're a computer scientist, you're here in red. It was bad because there just weren't any computer scientists anywhere. And then you got up to here, and since then we kind of go like this, okay? It was bad then. It's worse now, okay? All right, there aren't many women, okay? Why do we care? If you were here at the beginning, Mitch's talk did a really good job of talking about some of this, right? Globally, ideally, we're altruistic people. We'd like the world to be fair, and we'd like it to be equal. And, you know, it's not. But selfishly, if we look at the fact that computing addresses really important challenges in making the world a better place, and we know from experience that the more diverse your design team is, the better your solution's going to be. If we're going to have robust solutions to those design challenges, those important things, we need diverse design teams in order to come up with the solutions that would be good enough for us in our selfish selves. Okay? Why do we care in the classroom? This is sort of my day job. There are a lot of dynamics of being a token, right? If something goes wrong, and computing is hard enough that something will go wrong, right? You look around yourself and say, oh, I just went splat, and there's nobody else in this room that looks like me. Maybe I'm not supposed to be here, right? And then there's an additional weight, which is represented with the XKCD, right? If some guy gets up there and makes some error, blatant flaming error, that guy is not good at math. If some woman gets up and makes that same error, girls suck at math, all of them. Because to the people watching, you're kind of the only one, right? There isn't room for more than one. And you know, I promised there would be literature, and I'm an academic, so I've got citations in my talk. There are bibliographic references at the end. You can look it up if you want. Some of what's happening in the classroom as a result of the fact that women, I could say, tell much the same story for minorities, for blacks and Hispanics. It's very much the same. I won't talk it, it's not my personal story, but it's much the same. Self-efficacy and self-confidence. This is the story. I'm here, something difficult happened, and not believing in yourself to go on, because the evidence around you is that people like you shouldn't be doing this. In general, what I've observed among college students, and particularly among beginning college students, is that gap that students come in with the different levels of confidence, right? Often based on their previous experience, whether they have it or not. Their belief about how important that experience is much bigger than how important it actually is, right? A good instructor can do a lot to even that out, to get everybody to where they need to be, but people think that that lack of experience is really important. Women are much more likely to think that they're the only ones with that lack of experience, and they should just perhaps give up now. Okay? That graph there is not computer science students, it's economics students, but I would bet anybody $100 it works the same in computer science. What it shows is it's a distribution as you go across the bottom. It's the grade in the first class in the major. So these are the A's, A minuses, B pluses, B minuses, down like that. Okay? The vertical is what percentage of the people that got that grade stayed in the major, persisted in the major, okay? The blue bars are men, right? So if you look at, blue bars are men, red bars are women, you look at the A's, right? You give a student an A, right? An economics student, computer science students, you give them an A, right? They're equally likely to stay in the major, pretty much, right? If you give men lower grades, it really doesn't matter. They're just going to do what they're going to do, right? You know, once you start getting them D's and E's, F's, they're probably going to get the message, but it takes that, right? With women, they're starting to get discouraged. They're getting the discouraging message, the amplified message of society, starting with A minuses, right? And it's a completely different curve of who persists. This is a set of economics classes at an unnamed university, right? But like I said, I would bet that you would see that same distribution, something like that, in intro computer science classes. What happens is you see them leave not because they're failing out, right? A minus is not failing out. You see them leave in some cases, and Seymour and Hewitt did a really good job of interviewing people. They're leaving not because they're failing out. They're not leaving not because they can't do it. They're leaving because that A that they're getting right now, that A minus, they were working really hard for that, and they've heard it's harder next year, and they're not sure that they can work any harder, right? And so they leave proactively, not realizing that next year you're going to be smarter. And yeah, it'll be harder, you'll be smarter, you'll be fine. So that's what happens. And that's all kind of confidence. That's what's happening inside. There are also measurable effects from being a minority and being a stereotyped minority on performance. And this starts with the work of Claude Steele and some other people since then. The basic way you can see this is, let's say you're going to give someone a difficult math test, right? And at the top of that test, you ask about their ethnicity. And originally the work was talking about math, and it was talking about African Americans. You ask their ethnicity, right? By the act of asking and reminding someone that they're African American, their score goes down, right? Just from the act of asking, reminding them that they are a group who is not supposed to do well on this test, right? There are lots of ways that you can see that it's not just that there's a racial difference in performance, right? If, before you give that test, you make a comment that research shows that performance on this test does not correlate with ethnicity, then asking that question does not have an effect on how well people do. If you tell them race doesn't matter, right? This happens with women in math. It happens with any group who's not supposed to be good at something, right, and is underrepresented. One of my particular favorite examples of how this is not real difference in competence, this is difference in perception and how it influences you, is the work of She here. They did this experiment with a group of Asian American women, okay, and they did that same kind of math test. What they could show is if at the beginning of the test they asked them a question that was about their ethnicity, right? What language do you speak at home? That triggered the fact that they were Asian and they were supposed to be good at math. Their scores went up, right? If you ask them a question about their gender, indirectly, like their, what about their roommates or something, they were reminded that they were women. Their scores went down. Same group, same abilities, right? That's what happened. So that's the situation. I'm going to take another personal interlude. I've spent much of my career as a professor. I left Carolina. I did a couple stints somewhere. I landed eventually at UMBC and did the basic research, promotion. I was on the verge of becoming a full professor in '08 when two things happened. I had a stream of women come through my office with stories that made me sad, right? And I got a call from my president, Freeman Hrabowski, who can talk anyone into doing anything, right? And Freeman said, why don't you direct our Center for Women in Technology? And while I probably would have said yes anyway, the fact that I'd been primed by this stream of women with their negative experiences meant that I did that. So this is what I do now as my bonus job. I still have my basic my professor hat. I still do research. I still do all that. I do this too. I direct our Center for Women in Technology, which is committed to increasing the number of women who participate not just in the use of technology, but in the creation of technology. Okay? We do this through four things. The first is a set of scholar programs. We have 3 of them, basically with different target populations. See What Scholars has been around for, we're going on 14 years. It's for new freshmen. It's really about gender diversity. We've got 95% graduation rates in these majors, which is not what happens normally, trust me. We've got T-Site Scholars, which are for community college transfer students. Same group of computing and engineering majors. It's funded through NSF. We broadened our definition of diversity there, and we're including underrepresented men and non-traditional age students. It also has a socioeconomic component. And our newest one is Cyber Scholars. They come in at different times, and we're using that broader definition. It's really just the computing majors, and it's for people with an interest in cybersecurity. Pardon? Those are the numbers currently that I have in each of those programs.
Okay, so that's not over the 14 years, that's this year.
That's this year. That's how many I have, yeah. The Scholars Program kind of looks like this. There's a lot of community support. That's the key. We start with a weekend retreat. We've got monthly family meetings, cohort meetings, living learning community, which is academic jargon for we have a floor on one of the residence halls and they live together and we do programming as part of where they live. Lots of mentoring. We mentor with staff, with faculty, with peers, with industry people, with much mentoring. We do sort of course-like seminars at particular milestone places. The first year transition to college, the sophomore year as they start to think of themselves as leaders, and then the junior year to take advantage of the industry mentoring experience and think of themselves sort of as professionals to be, and then a bunch of other kinds of events. That's the center of what we do, and it's kind of our seed and our leverage. We also work on building a supportive community. So those numbers that Gary pointed out, that gives me right now about 85 total in my scholar community. We also work on having programs for the broader women in the college. Let me take a time out. I say women. What I mean is women in support of men. If I look at my scholars programs, even the CWIT Scholars Program that's about gender diversity, some of them have always been men, right? If I go back to why it's important, this diversity thing, this is a hard problem, right? In order to solve hard problems, you need diverse design teams. It's a diverse design team, right? We're training them to be allies. We're training them to be part of the solution. And that's why they're an inherent part of what we do. The affiliates as well. So affiliates, people who aren't we don't give them a scholarship. They affiliate with us on event by event, thing by thing, just voluntarily, right? So we have a peer mentoring program there. We do social events to bring people together that are specific to each of the majors. And then these sort of bigger lecture series things, which are mostly about interacting with industry professionals and building those connections. We do a number of things of looking at and improving the gender climate in our college, looking at data, running surveys, running focus groups, doing specific projects for specific departments, and then making recommendations and best practices. One of the things that's enough. That's not really the fun part. The people are the fun part. We also do a certain amount of broadening the pipeline. So looking ahead at changing the face of who arrives at college, thinking that they want to major in computing and engineering. We're a tiny little organization, so we do this at a relatively modest scale. We can't reach all of the high school or college or middle school students. We do it in two ways. Things that leverage well for the recruiting that we want to do for our program to raise awareness of opportunities, mostly among high school age girls. And then we have student-led programs for younger points in the pipeline. We like that basically for two reasons. We have more students than we had staff, so in terms of our resources, it's effective. But those programs provide good opportunities for our students to develop leadership skills. And we think of it as a little place to do that as well. All right, so let me tell some of the results of what I've been doing with my blood, sweat, and tears here. The CWIT programs, the CWIT one, we're on cohort 14 starting in the fall. We've got a 95% persistence rate in those majors, right? These students in general, they're well prepared. They would have persisted. They would have graduated from college. In my college in general, 50% of them would have graduated in some other major. They would have been biologists or economists or something else, right? They stay in technology. The T-Site and Cyber, we're at 100%, but that's because it's early days. We're getting ready for cohort 4 of T-Site and 3 of Cyber, so they haven't, it's small numbers there. The affiliate programs we've seen constantly growing. We started several years ago at about 15. Now we're over about 150, which is about 25% of the women in a college. We're working on trying to actually turn that into some quantitative evidence that we're making a difference, but it's really hard to measure the effect of something where people drop in and they drop out and you're really not sure who they are, and that's a challenge. We're working on that. The climate initiatives are also having an effect. We're an integral part of the strategic planning process that the college is going through right now. All right, so then let me go back to the literature for a little bit, talk about some of the things that matter. And you'll recognize some of these because it's the core of what we do in CWIT, and it's because we read the literature before we made some of our choices. The first is encouragement and validation. right? If you think back to that set of curves for the first class, and those women with the A minuses and the B pluses that are dropping out, right? You can combat that just by saying, you know, you're doing really well. Have you thought about going on? Have you thought about getting an internship? Have you thought about going to graduate school, right? You can counter that. Interaction, collaboration, and support, having a community, knowing you're not the only one makes a difference. Having female role models and critical mass makes a difference, right? You gotta have female faculty, you gotta have female TAs, right? You gotta have other women on your project team, right, to counter that. And the other, there's a fair amount of evidence that women, and I think this is true of underrepresented minorities as well, can be motivated by different things, can be motivated for different reasons of doing computing, right? Certainly some of the experiences at CMU and in other places have said that if you make computing not about, I love to write code and I'm just gonna do this video game and blow things up, right? If you wanna make it, if you make it about saving the world, having a purpose for computing, you're gonna attract a more diverse set of people to the field. And this is one of the things that I really like. The AP is developing a new AP computer science course right now with sort of that idea that it's about what you can do with computing. It's not, this is how you write code. I said there'd be references. There are references, you know. I can send you those. I don't know if we're archiving any of this. And I'd be happy to take questions.
Have you tracked the young women after they leave your CWIT program and they go into industry? What happens? Do they stay in the field? Do they change fields afterwards?
That's a really good question because statistically, across the nation, mostly they don't. The pipeline leaks more once you get to industry because industry is not as welcoming as it should be. We don't maintain connections with all of them. Some of them graduate and disappear. The ones we know, they stay in the field, right? And that part of that, I think, is because of a couple of things that we build, right? A consciousness of what's going on, so they're not just passive victims of climate stuff. Connections, networks, ties to the field, right? And I think those make a real difference. What we haven't had a huge amount of so far is we've got relatively small numbers going to graduate school, right? They mostly go to industry, and that's the path line. Yes?
One comment, in the university that I'm in, we have a school of computing rather than a department of computer science. Within the school is a division of computer science, traditional, but also a division called human-centered computing. And that has been much more successful at attracting minorities and women. HEC is a blending of computer science with the social sciences like psychology and sociology, but also education and so forth, and things like this. And coming up with projects, the faculty of HEC is also more female, or has more female faculty members than traditional computer science does. I mean,
Right.
That goes what you were just saying. But that has been much more successful in attracting the minority and female students than the computer science division.
Sure. So we have a similar situation. We have a Department of Information Systems which has a program in HCC, and they have slightly higher percentages of women in them. And I think particularly in HCC, it is part of that. You know, ours have our HCC program has a particular emphasis on accessibility and making computers accessible, and that feeds into that having a purpose for the computing, doing good with the purpose, and I think that's part of what's going on, and that's good. Right? But I think we can do the same thing with core computer science as well. I really do.
Right. I have a second comment, which is tied to what you just said.
Yep.
It's interesting that you started your graph at 1985 and showed, you know, the decline of women in computer science, because at Clemson University, where I've been, in the early 80s, our computer science majors were predominantly majority female.
So that was not usual. Nationwide, it would have been about a third in the early 80s.
Well, at Clemson it was majority, and in addition, the top students every year for the first 5 years, the early 80s, were all female. But then something happened, and I don't have an answer to this, but something happened in 1985, 86, and...
So Mitch just did a really good on this, the very first talk in this session, right? Some of it was advertising, some of it was the image. Before, say, the early 80s, there wasn't a national vision of what does a computer scientist look like, who does this, right? It was new, nobody really knew what it was, there wasn't an image yet. Starting in the 80s, there became an image, and it was white and male. And that's when you see things really happen. Kevin, can you tell?
So I'd be curious to know, you must be facing this as well, you know, undergraduate programs are bursting at the seams all across the country.
Yep.
And so we have very serious issues with underrepresented groups, compounded by the fact that we're treading water as fast as we possibly can
Yep.
to just offer courses. And so there's a tension between trying to focus on just getting folks through the door, not turning anyone away, with trying to do something out of the box to deal with diversity. How do you guys manage that tension?
I think that's a challenge everywhere. The first thing is, you don't want more students, right? We don't really want more students. We really don't want more students, trust me. But we could double the number of women and we wouldn't notice that we had more students, right? Because there are few enough that we could do that. And we would be stronger as a department that way. We would be better. But yeah, where I am, we're having conversations about how do we, to the extent necessary, limit who can pursue the degree. And how can we do that in a way that doesn't damage the diversity? In terms of gender, in terms of race, in terms of economics, in terms of, in our case, geography, where in the state did they come from? And how can you make those choices and those thresholds without damaging it? I think that's a huge challenge that we just need to keep asking ourselves. I've got one more way in the back.
Yeah, let's try to wrap it up in 1 minute or so.
Sure, and this is just a comment. Someone had asked about following women, and for me, I had gone into development and then leading development teams and did pretty well, and then I decided to have a family, and probably you see my 3 girls running around. And so my biggest challenge is, at this point, where do I start getting back into the industry? Because I can't imagine going in and leading after not having worked for 10 years.
Yeah.
And that's more a
You probably
women
need-
versus diversity issue.
So I can resonate that with my sister teaches high school Spanish, right? She, when her kids were born, she took a couple of years off because, you know, high school Spanish doesn't change, right? Computing doesn't, right? So I don't know if I would, so I took very little time off right after my kids were born. And I don't know if I would have made different choices if I felt like, it's hard to tell. I loved what I was doing, right? I wanted to go back, but I might have made different choices. I think you have to intentionally start a new chapter, right? And redefine yourself and go from there.
Thanks again.